Don't do it. Not a good
Hey.
idea because I use
Oh, wait, let me switch my.
Notepad plus plus. Oh, okay, I'm gonna let Anand.
Oh,
All right, here I am. Okay, great. Great to be back. Are you guys excited too? I hope so. Anyway, there's only 11 of us, so we're gonna either the other people didn't get scared away. Let's wait, okay? So I want to wait for some of the um, um, uh, you know. Uh, some of the people who actually brought up some really interesting discussion points last quarter, last class, right? I think Isaiah said something really interesting, and I'm pretty sure, was Vivian? Yeah, Vivian. She's not here. Yeah, she said some interesting stuff too. So yeah, let's give them a couple of minutes. In the meanwhile, no, there she is. In the meanwhile, Isaiah's not here yet, right? So let's start. Yeah. Oh well, it's only 8:01. We got a bit of
I
time.
believe it was. I can't remember who asked, but they're talking about IDEs, and I believe you said Visual Studio was decent.
No, actually, I said maybe I said use Visual. I don't use Visual Studio, but I know it's good. I've tried it. Right? It's cool. It's just that because I have ancient baggage that makes harder system easier to use for me. Yeah. Also, it's free, right? It's free.
Yep. I think it's probably a little more streamlined than what I do, which is Notepad plus plus, and then executing or compiling all the code using command line.
Yeah. Hey, you know what? Either you or anyone else who has time. I think several quarters ago, when I taught a class face to face, I think this class face to face, I had a student, right? Her name was Virginia Bao, right? And she was, and I think that was around the time when Visual Studio came out. It was like a few years since it came out. It was like a baby, right? So everybody was raving about it, and Virginia was, also one of the key enthusiasts. So she made a couple of videos for CS2A students on how to set up Visual Studio, right? Unfortunately, because I've not done a great job of categorizing the stuff, so our channel there is basically just a dump of everything that we recorded, right? Starting from little snippets in class and all kinds of junk, right? So it's in there. It's one of the very early videos from maybe a couple of years ago. I think it was posted by user Virginia something. Okay. Well, if not, doesn't matter. Why don't one of you? I say, yeah, that's what I was getting at. Really, I think that because since then, Visual Studio might have changed. A lot of new features might have been added. Some of you who are very facile on Visual Studio, maybe put together a 10-minute video on, for fresh CS2A students who are just starting. Here is the first thing that you will find most useful is getting Visual Studio installed, right? And if you can walk through, one for Mac and one for Windows, maybe, I don't know, see how it goes. If you can create those two videos, we can post them on our channel. I don't know, we'll come up with some way in which we can basically have a sub channel or something with resources, where the necessary resources, right? So, or at least create a playlist, right? Create a playlist, and share that on Reddit or something like that. Yeah, that'd be good. Yeah. By the way, again, hey, yeah, okay. Well, here, Mark, someone shared a personal phone number, I think, on chat. I didn't see the chat, but it just flashed on screen. Let me see. Mark, okay. All right, okay. They say, hey guys, please don't do that. Okay, so now that means Mark is not going to be able to share the chat, or I won't be able to share this chat window, right?
Oh yeah, that's right.
Right. So or someone like Mark has to spend like an hour or so scouring through the video and all these places and finding out if people disclosed crazy stuff. And it basically just not wasted, it was like 2 hours for me. Just following up on this stuff. It's not a big deal, but I don't, at the same time, I'm still not 100% sure that I got everything. right? So hopefully you're also careful. Anyway, so what time is it? Yeah, we still got time. How about this, okay? I'm just gonna fade into the background. I'll just put myself on mute. I'll disappear from the video for about 5 minutes. You guys carry on a conversation of your own. We'll wait for Isaiah. Oh, there he is. Isaiah's here. Okay, and anybody else? I don't know. But, all right, 5 minutes, okay? So that we have a few students missing yet, I think. So 5 minutes. Let's start at 8:10. We have plenty of time. In case you want me to come back and talk about specific things that are still confusing, happy to do so. Just yank me back, okay? Or else just feel free to converse amongst yourself, and it'll be cool because this is all going to be on a video. Maybe you can take a segment of this and TikTok it, and it might be viral. Who knows? Okay, all right. So I'm going to disappear. You can call out to me, right? You can call out to me. I'm not going to be looking at chat, right? Already, I don't look at chat.
Okay. Do you mind if I just point something out for everyone? So I have this on Reddit and I haven't fixed it yet because I actually learned that yesterday. Someone pointed out to me, I think it was Aliana, that I was doing this part of the calculation incorrectly. You'll notice that 13 is correct, but the exponentiation is completely backwards. It should be 3, 2, 1, 0 instead of 0, 1, 2, 3. So don't do it like this, or your numbers.
Hey, before I disappear, I'm sorry to interrupt, Mark. Before I disappear, because I want to say something very specific for the point that Mark was actually making. He went the other way, and this is exactly the point that Isaiah made at the end of last class, if you remember, right? So he was going with exponents the other way. So that is an intuitive way of doing it for someone who's used to some left to right language. So yeah, okay, cool. I just wanted to make that point because it's related to the last lecture and what Isaiah said. So I'm sorry to interrupt. All right, so I'm getting away for good this time.
But yeah, point is, do it the other way. Put it, your highest power is on that first digit. That's all. Probably, I mean, you might be able to see it, but there are 2 links to YouTube that I've put in the chat. The first one is for nonlinear media, which has access to all the lectures from the previous quarter and some in this quarter. And then the second one is a tutorial on adding floating point numbers, which I recommend you view before looking at the quiz. Because yesterday I was a little bit out of it. I accidentally started quiz 1 and only got a B. Yeah, that wasn't so great.
While reading the module 0, well, thank you, Mark, for sharing the quiz 1 experience. And when I'm reading the module 0, I have 2 questions. One is this about the pounder. Is the answer 1? Because there are 2 questions hiding behind. Yeah, I do have the question about to distinguish 2 numbers, which one is the negative one, which one is the non-negative one, but I cannot figure out the exact answer after reading this paragraph. And to me, the first question I ask myself to answer this question is what is the biggest non-negative number, which to me it's 1, 1, 1, 1. And in this case, the minimum negative number will be 1 in order to make the sum 0. So what do you guys think?
Well, there's 2 ways to have like negative numbers, right? There's one where like the very first number is 1 or 0. And then there's the other one where it's like 2's complement, right? That shows you if it's negative or positive.
Yeah, I was using, I automatically using the second way, like make their sum to be having a 1 that is out of the maximum bit number. Yeah.
So we're talking about 4 digits.
Yeah, because it's nibble.
So I think for the negative, we're to tell if the number is negative or not. It says that you look at the most significant, the MSB, I think, most significant part of it, which is the first part, the 1 or 0 part. So it's I mean, I could be totally wrong, and I might have just read it wrong, but I thought that 1111 could be a negative number with context. I mean, so like you said, it's positive, but it could be negative because of the first one, maybe. So, and I think that it's my impression that the context of the ones within the whole like bunch of code that you have is going to like help us figure out as well as that first number.
I think like what you were saying, that you know how you make the most significant bit make it equal positive or negative. I think I was like looking at a video where it says that like if you add like -5 and negative or +5, you don't get 0 like you're supposed to. You get like 2 or something. So there's like a problem with that notation.
So I think one thing to keep in mind is that there are 2 ways to represent negative numbers in binary. You've got signed integers, which means that the most significant bit is reserved for indicating positivity or negativity, 0 being positive, 1 being negative. And then 2's complement, which is that crazy system we saw where you find the 1's complement and then you add 1 to it. So I think perhaps one strategy, just proposing it, to find the biggest negative number that you can find would be to go to the biggest positive number that you can fit in one nibble, which is 1111, and then find the 2's complement of that value, just as a proposal. Does that sound reasonable?
Yeah, can we go over like an example of how to do 2's complement?
Well, I mean, mod 0 is right there. Scroll down. I got a cough.
2's complement. I think it's on the top somewhere.
Okay,
Yeah.
might be, yeah.
2's complement notation.
Mm-hmm. Actually, I should have it open on my side as well.
Basically, this is the second way.
So the complement of 1111 would be 0000, and then if you add 1 to that, that would be, I think, 0001, which doesn't sound negative, but through 2's complement, I think is negative in that context. Because the complement of 10001 or 1001, the complement is 0110, as you can see, and then the 2's complement is just 1 greater than that for 0111.
Wait, so for when you do 1's complement, all you're really doing is just flipping the 1's and 0's, right?
Pretty much, yeah. And then you add 1 to that to get your 2's complement.
And 1 would just be 0001, right?
In binary, that would be 1, yeah.
Yeah, but like I guess the point is like a 2's complement is only a 2's complement with if there's the initial 1 as well, right? So like what if we just had a 2's complement of 1111, but we didn't have the 1111 part? Then it would be positive. Like we could interpret it as positive 1, right?
Yeah, without
Like
knowing that it's a
theoretically.
2 complements number,
Exactly.
you wouldn't know that it's negative, and that is something that should be discussed at.
Yeah, so like I think that's where like I think context also plays a role. Like we know, just guessing it, that it's negative, but it's about how our whatever we write or whatever we plug our information into will receive that data, information data. Not sure which one to use.
I see. I think that makes sense. And also, if we get a number and to me, I automatically think that it's a positive one. And then the number that we get after using the two complement method, I think that number is the negative, but that I think it's too subjective. So I think the context do matters. So we know the meaning behind the number before. And yeah. My second question is this part. I'm not quite understand how to convince myself that it's not approximately, it's exactly the value. I know that F is equals to the hex proposal 2 is 1111. So I do understand for this part. Why the 0.111 is similar to
So
0.FFF.
I think it's because as you keep going, you get closer and closer and closer to 1. Let's take binary, for example. Past the dot, the radix, you've got 0.5. It's 2 to the negative first. Then you've got 0.25, which is 2 to the negative 2. Then you got 0.125, 2 to the negative 3. As you add them to more and more and more, as you add more digits past the radix, you're getting closer and closer and closer to 1. And I guess it's converging to 1 as you add more digits. Does that make sense?
It makes sense when it is 0.999.
Yeah.
But I think 0.111 is getting closer. If it's a digital number, then it's getting closer to 0.2.
I disagree.
Well,
You have
it's
to
not.
translate it.
Sorry.
Yeah, as she just said, you got to translate it from binary to decimal. Remember, what is that
Oh, in
one
binary.
past this? Yeah, what is the 1 past the 0 equal to? It's 2 to the negative first,
Yeah,
which
yeah.
is a half, and then the second
Understand.
one is a 0.25. We add 0.5 to 0.25, you get 0.75. That's another 0.125. It gets closer and closer and closer to 1, and then eventually it does reach there, and it's kind of a leap of faith at that point, but
I got it. I got it. Sorry. I
Sweet,
forgot to
yeah.
read this part in binary.
Okay.
Yeah. Thank you. I have no problem about this.
So what you're saying is that all these at the end are like the very last value that you can have in like hexadecimal, decimal, and octal and base 27, right?
Yeah, in hex, you got 15 times 16 to negative first, and then the second point past the dot is 15 times 16 to negative 2. And I don't want to run those calculations right now, but
Yeah. But what you're saying is that they just get really, really close to 1, right?
Mhm.
Okay.
And the more digits past 0 that you go, the closer you get. And if it's not a finite number, but it's a repeating number of digits, then in fact, yeah, it converges to 1.
Okay.
Thank you.
Probably have to use calculus to really prove it, which I don't feel like doing in binary. But yeah.
Well, if you guys have any questions, you can ask me. Or we could also talk about fractionals, fractionals and how to represent fractions and so on. Or we could still talk about two's complement. It doesn't matter to me. This is just a discussion, and I'm here to answer any questions that you guys might have about these things. And by the way, it seems like a great discussion is going on. I just, when I came back, I was looking for a time to say, well, is this a good time for me to got back into the conversation, and because and I said, yeah, let's wait for a time when you guys are not talking about something interesting, and that never came, right? So you guys are just on a roll basically. So I'm happy to just sit around and enjoy the show. Really, it's my Tuesday morning show and Thursday morning show. All right, cool. It's fantastic. So yeah, of course, anytime you guys want to talk to me, you can just pull me in. If you have a question, you can ask me, right? Or this thing here, whatever that thing is highlighted. If that's a question, yeah, you can ask me. And if it's relevant, or if you don't want to ask here, you can always ask the same question in the Reddit, right? You can take that question in the Reddit, and what is that? Oh yeah. All right. So yeah, it's not directly computer science, but it's actually it's more number theory, I guess. Well, not even, it's just mathematics. Yeah, it's not directly related to what we're doing here, but essentially, if you take any radix, right, just take any base, right, base 10. So suppose someone claims that 0.999999 is not only convergent, meaning it's arbitrarily close to 1. They claim it is actually exactly equal to 1. So that is that's a phenomenal claim, isn't it? Because there you're asking them to make a leap of faith between, it's not that dx smaller than 1, it's actually equal to 1. So how do you make that claim? Can you prove that mathematically? And then it's very simple, right? So you can actually you don't even need math symbols, right? So you can actually prove that using words in Reddit. Just like some of the most beautiful, elegant proofs in maths. Even after you've seen all these big proofs and work through it, oh boy, that's why this is equal to that. You find that some of the simplest proofs, right? Proofs like Euclid's proof that there is an infinite number of prime numbers, right? It doesn't even require math symbols to prove that. And I'm sure there's tons and tons of proofs like that. Not just Euclid is just one example, right? You take all these ancient civilizations, and they have these and these proofs, but these math symbols are something that we just invented, in the last several hundred years. But mathematics has been around, so they've been using different symbols, different ways of thinking about this. But at the same time, what's common to all of this is just the driving towards the truth, so finding out what makes this absolute sense, right? And so from that perspective, you don't need a particular language to express these proofs. Math just happens to be convenient for some of these other things. But if you look at Euclid's proof, that it's so mind-boggling that someone could have the audacity to claim that there's an infinite number of prime numbers, right? Because if you take just same as someone who comes and claims that there are basically an uncountable number of fractional numbers, or even rational numbers which are fractions. There's the same. You can put them in a one-to-one map between integers and rationals. So there's the same kind of sets, right? Whereas if you take put real numbers there, the square root of the square root of 2 can never be a fraction. Right? So that was proven a long time before we started using our kind of symbols with mathematics, right? But such a simple proof, and it's also very, very nice, right? So you can talk about these things in the Reddit too. It's kind of marginally related to what we're doing in class, so that's very nice. Yeah, lots of things we can talk about and waste time, precious CS2A time talking about. But no, we shouldn't do that because there is a lot of exciting stuff we can cover, even in 2A. So just this week is we're going to do this data representation thing. Next week we'll start coding. And hopefully there more of you will have an opportunity to drive. It's actually really great, real fun. It's like going go-kart racing, and it's the first time you sit behind a wheel. I'm not really a car person, but I know some other kids that you look at them and they know they're car people or driver people or something like that, right? So they sit behind the wheel, their eyes basically just light up like like the car lights. Yeah, it's like that. When you start driving, initially it'll be a little scary, but you got to get the taste of it, man. I mean, so it's like skiing or any other art, any other thing that you want to get into. Initially, it's a little intimidating, but once you start, start riding, or once you start driving, it's actually a great deal of fun. That's why I think towards the end of the quarter there'll be more competition to take these slots. When it's not even this week, right? This week Mark and I and a few other people can can take care of these things, but starting next week, I think when we actually start coding, it will be great if you can take turns in a nice way to come on stage and code with the rest of us. And also watch the previous videos, right? The previous quarters videos for how the coding exercise happens in class. We just pick some problem, right? Or someone might call out a problem, we pick it up, and then we start coding. And then we make mistakes, right? We go back and correct those mistakes. We run it, it doesn't work, right? And then and it's really cool to do this, right? This is a chance to do it because most of the time what happens is that I've spoken to past students, right? Past CS2A students, and I think one of the things they tell me is that they're really scared when they to compile the programs. So they say that and one of the students actually came to me back in the time when I was using, when I had face-to-face office hours back on campus, right? So one of the students came and she actually finished all the assignments, right? She's finished the assignment and she's done it, and she brought the computer to my office. And that's, during the time when I was actually looking at code and things like that. I don't do that anymore, right? She brought the computer to my office and she said, and she hadn't submitted, some assignment. And I said, and she showed it to me. So is this right? Can I submit it? I said, why don't you submit it and find out, right? But she said, no, I haven't even compiled it yet, right? So I look at the code, and the code is actually very nice. It's bulletproof. It's right. Everything is fine, right? I said, why don't you compile it, right? And then I have to weasel it out, right? So many students don't even tell you these things. And then I find out they're actually scared to compile. These first few programs, students are scared to compile because the compiler could come back and say everything is wrong, right? Right. That is not the way to look at the compiler messages, right? So I think that's why I think the in-class driving sessions are really useful, right? Even more useful, I think. Hey, some of you other guys, you switched off your video, right? I hope you know, right? David, Isaiah, Srikaran, and all these guys. Yeah, okay. You got to be here. Even if it's okay to switch your video off, you got to be, as long as you chime in with your voice from time to time. That's fine, right? You just need to make sure that you haven't switched off your video and gone off to Starbucks or something, right? So, all right. So, so what was I saying? Yeah. So. Students, compiling on screen, which is great because we're all in the same boat. We're all trying to compile things. We're all trying to code. I'm coding with you guys, right? So we're all coding together, and we try it and it doesn't work, right? And then we, because we're going to be coding in some, I don't know, replete or some kind of window, right? And we'll see all the errors, and sometimes even worse than that, we'll see things that it doesn't work even though the compiler says no errors, right? So we think the logic doesn't work. What we think, our head, the program runs differently in our head and on the computer. So obviously there's a mismatch there that needs to be corrected, right? So those are difficult kinds of problems, and we run into those problems. And I can, many promising programmers have been ruined. Right? Many promising programmers have been ruined because they think that, this is a problem that other people haven't faced, right? It's coming to me. I'm the only one who has these problems, so I'm not cut out to be a programmer. No, so that's why I think this is really cool, because then all of us can do this. But then we can say, no matter how long you've been programming, you're still going to encounter the same thing. And so it's better to get around to find a way to deal with it, right? So I think that is it. Just like in real life, right? That's in real life. I think in my life anyway, right? So when I was young, there are all these problems, right? Problems. Everybody has problems, right? There's all these problems, and we think, oh, these problems. Yeah, I want to deal with these problems. So I spent a great deal of time and effort trying to craft these incredibly clever solutions so that I don't have to deal with these problems, right? So and then after time, I also found that I was going overboard. So I was not only solving the problems that I don't have to deal with, so I was also solving problems that I won't even have to deal with in my life. Right? Maybe I have to deal with. Maybe slim probability, but my probability distributions are all so skewed that I was solving problems. I was getting obsessed by setting things up for that are not even going to be right. So and that point, and then you reflect and say, what the hell am I doing? Right, solving all these problems because you can see that the stream of problems is actually infinite. So the only way I can really solve these problems is by dealing with them. Because once you've dealt with them, it doesn't matter if you have one problem or a million problems or infinite number of problems. You can deal with them, right? So, so that's that kind of factoring out. That kind of factoring out is what I'm saying. So in C++, I think what I see is that a lot of times during our early programming development stages, we spend a lot of time trying to say, well, I got to somehow write this program in such a way the compiler doesn't throw these red flags or this, all these problems, right? Because I'm scared of these problems. So if we are scared of it, we try to avoid it, and then we shut it away. It's there. It's there. We got to deal with it. Right? It's out there. It's got to. Sometime we got to face it, right? Right? It's there. But I think the better way to become a programmer is to say, no, it's going to be there. If I live for 1,000,000 years and I still do something, I'm not 100% careful, whatever, right? So something's going to happen, I'll just fix it. When it happens, I'll fix it, right? So that's the mindset to be in. Right? So just say, I'll take it. Yeah, I'll take it. If there's something wrong, I'll just try and fix it. If I can't fix it, yeah, screw that, right? And move on, do something else. But if that kind of mindset to get with a program is very hard. And I'm sorry, Mark, you've had your hand up for a while. It sounds like, it looks like, I'm sorry. I wasn't.
No, I just popped it up. I was going to say, so would you recommend a habit? What I still consider myself not all that good at coding. And so what I do is I test everything with basically every line I write. Because a good chunk of the time I write a line, it's just,
no, I'm just saying that
I was like, nope.
everybody does the same thing, right? Everybody does the same thing. It's just that after a while, you do it so often that you stop thinking about it. Because it's just the thinking about it that is worrisome. Even life problems, it's just thinking about it. If you've got an automated response to even life problems, you can let the automated response take over, so you don't have to think about it. You can think about having fun, right? So that's the goal of everything we do. And I think in programming, we do that, right? Everybody we microcheck and we get paranoid. So it's just I think the point I was trying to make was that everybody goes through this, but some people feel that they're the only ones going through it. Right? And therefore, as a consequence of feeling that they're the only ones going through it, this is my hypothesis, right? May not even be true, right? Maybe we just need to survey a lot of people who just gave up programming, right? So as a consequence of thinking that they're the only ones going through it, they say, I'm not cut out for it. Right, so for this thing, maybe I need to be doing something else. Maybe I need to be studying drama or mathematics or whatever it is, right? So it's unlikely mathematics because computer science, mathematics. This is maybe a non-STEM field or something like that. So, and I think that's the reason, because it's now everything is done in secret, right? And that's the problem, right? There's great people who've done great things, but a lot of things they do is in secret, right? Or not in secret. It's not willingly in secret, right? They just don't feel the time, or I don't know. Maybe they've not got the teacher gene in them, right? Or I don't know. Maybe they don't feel like it's worth sharing. So it's just routine work for them, right? So you just wake up one morning and okay, let's do this, man. All right? And I don't know. There are people like that, but I think it is worthwhile to expose your struggle. And even after you, especially for the people who have overcome the struggles, I think they can expose their struggles to say that, don't give up when you're still struggling, because I went through CS2A. I went through all the blue quests. I didn't drop off after quest number 7 or 6 and say, someone else is going to. I stuck through and I did CS2B and then no. But actually, I thought that I said it's only a hypothesis, but it actually seems to be getting increasing evidence, because I look at some of the posts that the CS2C students, not all of the CS2C, the ones that go on to complete CS2C, right? The last question in 2C, and I look at some of the posts they make, and almost invariably they are, even though they're very frustrated, right? So I'm pretty sure you're all frustrated with the questions. Well, maybe you haven't started questing, but very soon you will be frustrated, right? And something that you have to look forward to, because frustration is not something you try to avoid, right? So I think that is the danger, right? So don't try to avoid it. Be frustrated, right? And then if you're frustrated, go away, but don't avoid it. But you're going to come back to it, right? So avoiding is saying that I'll just not do it now and not do it ever. I will find something else. Right, and then you run the risk of jumping from one thing to another, because everything gets frustrating at some point, right? So, and then if you just keep on giving up at the time it gets frustrating, then there's enough things in life to keep you occupied for the rest of your life, any number of lives. You keep jumping, and I don't know, it doesn't lead you to where I think you need to go. Maybe it does, I don't know, but I think be frustrated in programming. It's a meta discussion about programming, right? We're not even talking about C++ here, but I think it bears on to the development of the student through 2A or 1A all the way to the C, or 3A, 3B, 3C, right?
Professor?
Yeah.
So you said we're not going to be doing any coding
this week.
review in this week. So I know that you said we were supposed to review variables, expressions, precedence, input, output, logic, operators.
Oh yeah. Well, the reason I'm saying that is that I would rather just use this first week to just focus on the data representation issues, and then even if you just start with hello world and all the expressions and everything on Monday, right? Next week. We're good. We got a lot of time. So look at the last quarter, right? These last couple of lectures, we were basically just hanging around, having fun, right? So talking about useless things. So we got a lot of time. We can take it slow, and that's the other thing, right? So I'm pretty sure we have a spectrum of people, right? We have experienced programmers, people like Mark who've been in community colleges, even taught programming, right? And then there's other people who just want to try to get a taste, right? Other majors, right? I think Vivian, you're doing another major, right? You're anthropology or something. Yeah, I just happened to read all the introductions yesterday, right? So yeah, we have these varied majors and trying to get a sample to see what it's all about. And so I think it will be helpful. It doesn't matter, right? So just I have to keep this in mind more than you guys, that it is not required for CS2A students to master C++ in order, or get an A+, or master C++ in order, right? C++ is a taster. It's a CS2A is a taster. At the end, if you manage to complete quest 6, take your own pace, at your own pace. Up to quest 6, take time. The thing is to just develop a taste for it, which means you have to enjoy each step, right? It shouldn't be bitter. I got to get past it. That's not the attitude, right? So just enjoy it, take your time. And I can guarantee that we will make every effort to get you passed, right? We're passed. I have a high pass rate for CS2A. Only the students basically just give up, fail. Right. So
just for me, I'm the type of person who I want to get through the building blocks first, so that I can, because I know there's going to be more difficult concepts to comprehend, the longer we go throughout the course. And so if I'm introduced to these ideas sooner, then I can master them sooner, and then I'll have more time to sort of be stuck on things that are going to take a longer for me to absorb.
Yeah, there's nothing to stop any individual student from marching at their own pace. If you feel comfortable, you can also go ahead and do the green quests, right? So you can just work all blitz through the blue and then start the green. It'll get nail all the concepts in place properly, right? The data structure.
Yeah. No, I'm a complete newbie myself. I don't really know that much, but I guess I also downloaded the VS Code, Visual Studio Code. I spent an hour last night trying to get it to install an extension so I could compile within the program, the software. And my computer is so old, it just broke. So I think I'm gonna have to do what Mark said and do the command line compile, but I'm still trying to
work with someone in class who or some. I'm pretty sure even if it's an old compiler, old computer, VS Code itself is thin enough, and the compiler, even the command line compiler you're talking about using with Mark, that's what VS Code is going to use anyway. Right? Instead of you typing it in, VS Code is going to invoke it for you. I am pretty sure that if some of them in fact, if I go to some of the older computers, I'm pretty sure that VS Code will run, but even Emacs won't run, right? So Emacs is like a text editor, right? So Emacs even has gotten fatter and fatter. VS Code, is getting sophisticated features, coloring and everything, right? At the same time, it's also gotten thinner and thinner. And that's what they tried to do with Chrome, right? So they tried to do, at that time, all the Explorer, Internet Explorer, right? All all the browsers were getting fatter and fatter. And then they said, I'm going to make Chrome, which is really, really thin. And when it came out, it was, blindingly fast. Right, and very soon it became even fatter than all the other things that they were trying to get thinner compared to, and then stepping stones.
Isaiah asked the question, what C++ program should we download? And this is something that I was really struggling with yesterday, what to start with. So basically you can write your code in anything, Notepad++, like Mark was talking about. Visual Studio, it's called Visual Studio Code. It's also very nice looking. And you could install an extension that sort of like is very specific to C++. There's also something called CLion that also is like a program catered specifically to C++. But to be honest, it's a little complicated I mean, I'm new to this, so I kind of just wanted to download something right away and get started.
Professor?
Yes,
I
Chris.
was also having that problem, like getting started with like compiler, but then I watched this. I'm not sure if I can share this link with you guys, but this video helped me like get started, like even like helped me write the Hello World program.
Oh, you should totally share it, Chris.
Yeah, I just shared it right now.
Yeah. In fact, you can share it on Reddit also, right? Under the first
Okay.
class, you can share it saying,
Yeah, I'll
hey,
do that right now.
Yeah, you should do that with the Reddit so we could all find it. That'd be awesome.
Thanks.
But if you guys want, it's in the chat right now.
Yeah.
It's not going to say, if you put it in the chat, it's just going to disappear, right? It's not even going to be.
Yeah, I'm sharing it on Reddit right now.
Yeah, thanks, Chris.
Professor, I have a question.
Mm-hmm.
So I'm using Mac. Would you recommend using Xcode?
You use whatever you like. You know, have you used Xcode before?
Yeah.
You have,
but not much.
Okay. Well, you know, try it, and because Xcode also has a learning curve. Yeah, everything has a learning curve. So if you're absolutely at the beginning and you're making a choice between multiple environments and haven't invested already, that's essentially what it is. If you've already invested time and effort in one path, it makes sense to just follow that path, right? Because everything leads to the same place. So if you've already invested time and effort in one and it's going to lead you to the solution, just follow it, right? Unless you want to just give it up and try another one for the heck of it. I don't believe, I don't know, because I'm not an expert with VS Code, right? Someone has who's an expert in VS Code and Xcode has to chime in to give you the right answer. But I'm reasonably comfortable with Xcode. Yeah, see, everything has got some pain points, but
it seems like you're reasonably comfortable at everything. But I have a question. When we're doing the like, what is it called? The binomial 0, 1, 1, 0. Yeah, the binary. I'm not noticing on the chapter 1. Like, where is that in the book? Because like,
no, it's not talked in the book, right? So, thank you for Isaiah. Thank you for bringing that up. Okay, so this is data representation and binary. So most of the textbooks just leave it out, and I feel that it's so important for the rest of C++ that I wrote that module 0 and put it in Canvas so that you guys can read it before.
Oh, really?
Starting
Okay, let me go back to Canvas then, because I'm tripping. Module 0. I see only module 1. I didn't find module 0.
No, it's module 0.
Yeah, module 0, data representation.
Yes, so that essentially asks. In fact, many of the questions that you asked last class are in fact asked in that module, right? You can.
Okay, I have to go back and reread it.
Yeah. So read that module, and in fact, if you look at some of the speech bubbles in there in that module, you'll see that you'll recognize some of the points you made last class, right in there. Right. That's why I thought last class I thought that you'd already read it, but you should read it, right? Just download it today and start reading it. Before next class, you got to be like everybody, all of you, right? I'm not just Isaiah. Before Tuesday, I expect that all of you come to class really solid on data representation, because once we start coding, we're not even going to talk about, much. You could be completely. Essentially, after the data representation quiz, you can forget all the concepts, right? You could have incorrect concepts, incorrect data representation ideas, and you can still march ahead with CS2A and do a lot of things. But where the lack of knowledge in data representation will start biting you is when you get to some of the more advanced concepts, right? It could start biting you as early as when you start looping and you start using unsigned instead of signed, and all those things without knowing the distinction. Right, which you'll know if you did data representation, you'll know the distinction between these things. But I think that it will slowly catch up. This piece will catch up, and will. But you got to read it, right? Yeah, not just Isaiah. All of you got to get really solid on data representation. You can basically blow everybody else out of water if you're solid on data representation. You'll be solid in. Well, I don't think it's a one-to-one relation, but I think it's really strengthens your armor to know the fundamentals.
Professor. I think that's a really good. I think that's a really good point. And so I'd just like to say, I think because this class is discussion based, correct, Professor? So because this class is discussion based, we're only going to be able to learn as deeply
Yes.
as we can, as we're able to prepare.
No,
So-
thank you, Elizabeth, for bringing that up. Okay, even though it's discussion based, I'm going to try and steer deeper, right?
I guess my point is that like the more of us who read the material before class, the more of us will be able to sort of like build off of each other and contribute and ask questions and help deepen our understanding. So it's a really good idea to like even just like skim like the stuff like before class, because it'll make our brains tingle a little bit more, you know.
I think
don't
so.
know.
It's fun. It's fun,
Yeah.
and also it's always fun to talk about things we know, right? So in class, if you've already seen the video once, then when you're going to talk about things, you talk about things you know. It's a lot more fun, really, right? I think you'll find it's a great opportunity. This is great. You know, I love it. I love it that we're all getting into it together. Because that is the way that I wish that everybody's introduced to programming. Because when you go to a swimming pool, you got to see other people in the water, right? You can't just push someone into the water and say learn to swim, and you got to see other people also learn to swim, right? Yeah. Otherwise, you're never getting in the water.
Can I ask about two's complement? So I understand that it's supposed to be used for unsigned integers, and one thing. Well, it doesn't necessarily have to be an integer, but one thing that is a little bit concerning is that the number. How can we tell just by looking at it that it's negative, or is that necessarily that you can't? You have to know that it's a two's complement number.
Right. It's a good question, and I think it might have come up before in other discussions also. How can you tell if the number is a two's complement number or a signed magnitude notation or some, or it's just an unsigned number? It's a binary number, no signed bit at all, right? So how can you tell? And the only way you can tell is by the context in which it is being used, and by us telling the compiler, telling the computer, treat this 8 bytes as a signed character. Treat that 8 bytes as an unsigned. So we got to tell it. So in C++, starting next week, next week? Yeah, I think we'll next week, right? And I'll actually point out to situations in the code where we'll actually say to the compiler, saying, I want an integer and I want an unsigned integer, meaning I want to use all 8 bits in that character to represent my number, right? Or we can tell the compiler saying, no, I want a number, but this number could be positive or negative. I know I understand that I can only go up to 127, but give me one, assigned character, right? Which can go both positive and negative, but which can't go that big, that high in terms of any one particular magnitude. So yeah, I think we'll encounter these situations. That's why I said I think getting solid on data representation will really help.
Professor?
Well, can you go, Chris?
Oh yeah. So we were having a group chat yesterday, and we were talking about adding floating points to binary numbers, and we were just wondering if we can go ahead like over that today.
Yeah, sure, I can go over that. If any of you want to, have a specific question, what you don't understand, I'm happy to go over that, or a specific example that you want me to work through, and then I use that to explain some of the concepts. We can do that too.
Okay. So you use examples to explain concepts?
Yeah, sure, I can do that. Do you have a specific example in mind, or tell me a concept and then we can pick an example that we can do that.
I'm not understanding the binary concept in terms of understanding the value of the number past like 6. Like, how do we get 6 from that 01110 yesterday? Like, I didn't know how they figured that out.
Okay. All right. So I'm glad you asked that question, right? Because sometimes that is a question from the previous class, and I'm glad you asked that, because you're not the only one who has that question, but you're the only one who asked that question, right? But many people have that question and they haven't asked it. But I know many people have that question, but you're the only one who asked that question. So thank you. But what was the question again? Is how do you go from 0110 to 6? Yes?
Yes, that was the question.
Okay.
Thank you. Yeah. Okay. You got good.
So all we're trying to do here is basically, as humans, we've been used to 10 fingers, yes? So we go 0, 1, 2, 3, 4, 5, 6, right? So we have that symbol called 6 that we write in a particular way with a line, with a curved line, yes or no? Right, so we write the 6 like that. Yeah, but instead of writing the 6 like that, can I write it? Because if I go to a different civilization, a different culture, they might write the 6 differently. They might write the 6 like that, right? They might, or they could say 6 is that. They could use a, you know, an expression like that for a 6. Yes. So they could be different. It's just that it's a stroke of accident that we happen to use 6 like that. Yes.
Right.
Okay, all right. So in the world of binary land, okay, so there's a different planet out there, binary. They're not writing symbols like us, right? They're only using zeros and ones to write everything.
Genius.
Yes. Okay, so they write the 0 just like us as a circle, right? They write the 1 just like us as a 1.
Okay.
They write the 2, you know, they can do that too, but they have to write the 2 as a 1, 0.
Okay, so what's 3?
3 has got to be 1, 1, because, you know, think about what we would do to go from 10 to 11, that is exactly what they would do to go from 2 to 3. What do we, right? So we go from 10 to 11. So what do you go to from 9, which is the last available shape to us is 9, yes?
Yes.
Okay, from 9, what do we go? So we don't have any more shapes after 9, because in hexadecimal land, after 9, they have A. Yes? But so in decimal land, in our human land, after 9, we don't have any new shapes. Yes or no? We have 0.
No,
0,
we don't
1,
have any new shapes.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have, you know, we've used up all 10 shapes for the 10 quantities.
Yes.
Right? So now we want to say 11. Oh no, we want to say, we want to say 10, right? We want to say 10. After 9, we want to say 10. Right, the quantity 10, but we don't have a shape for 10, so we use a place value notation to say that, okay, so we're going to, 10 is going to be represented as 1, 0, right, which means that we have 1, 10 and 0 ones. Now if I want 11, all I need to do is add 1 more to the zeros part, right? So 10, 0, 1, 0 becomes 1, 1, 1, 2, 1, 3, 1, 4. And how far can I do that? I can go from 1, 0 all the way up to 1, 9. But after 1, 9, I have the same problem. What do I put after 1, 9? What do I do for 20?
You gotta change the front.
Right. I say, let's make the 2, right? Let's turn the 1 into a 2 and turn the 9 back to a 0.
Okay, makes sense.
Right?
So the
first, yeah, the gas meters. How do the gas meters go? Right? So this digit keeps going from 0 to 9. When it goes to 9, right, the next one will go 1 up, and then this will go back to 0. So think, you know, the gas meter operates like that. Yes.
Yes.
Okay, so that's exactly how we would do it if it were binary. Except in binary, you don't go from 0 to 9, you go from 0 to 1. So
okay.
0, 1. And then the next thing to happen is that the next guy is going to go from 0 to 1 and just go to 0 again. Yeah. So the way that these people in binary land would count is 0, right? And then 1, and then 1, 0, and then 1, 1, and then 1, 0, 0, right? Because same way that we do 99 and then 1, 0, 0. They do 1, 1, because 1, 1 is the biggest pattern they can show, right? So 1, 1, and then, you know, 1, 0, 0.
Okay, so
yes, and it's just imagine a gas meter. Imagine a gas meter at one of these gas stations, right? And imagine that they didn't have 0 to 9 digits on that wheel, right? They only had 0 and 1, right? 1/2 is 0.
Oh, yes, yes, yes.
Right, and they have a lot of these wheels, right? Because, you know, someone could pay for $50,000 of gasoline, right? So they could have a lot of these wheels, except that, you know, these wheels are not decimal; they're binary wheels. Right now, so if you think about that, it'll take a little while. I don't know, it may take a couple of hours of thinking about it. Well, what I mean by a couple of, so when I say a couple of hours of thinking about it, I don't mean.
Isaiah, do you understand what the professor is like trying to convey, or do you have any other questions?
I kind of do, but like I still get lost on the numbers. So like, is the next number 110?
For what?
like number 4 is 110, correct?
So 4 would be 0, 0, 1.
Let's start from 1. Yeah, let's start from 0.
So
Let's start from
I think
0.
I think
0,
Mark
0,
is,
1.
yeah. So actually, Mark, do you mind if I share my screen?
Yeah, of course. Sorry, I just wanted
Okay.
to re-represent that in a way. But go ahead.
Yeah. So hold on, let me see. How do I do this? Share screen.
And then I think you have to click on a specific window.
Okay. I think classwork file. Let's see. All right. So you guys see this black window? I'm not sure. Okay. So basically, in binary, like you know about exponents, right? Like something to the power of something like times itself however many times, right?
Yeah,
Yeah. So and so the way we signify the exponent is with this little upward arrow. I don't know how to call it. So anything to the power of 0 is 1, or yeah, 1, I think, right? And then 2 to the power of 1 is equal to 2, because it's just, 2 once. And then 2 to the power of 2 is equal to 4. 2 to the power of 3, 2 times 2 times 2 is equal to 8. And so basically, when we're thinking about binary, instead of doing like in decimal, we start with the ones place, then we have the tens place, and then we have the hundreds place, right? And that's how, and then we go to the thousands place. So if there's a 4-digit number in decimal, you're gonna have like 1,000 and something, or like, 1,110 and 11 or something. But in binary, the places hold not 1, 10, and 100. They'll hold 1, 2, 4, 8. So if you wanted to represent in binary, you wanted to represent the number 3. So in the ones place, we have 1, and in the twos place, we have 1. Because if you see here at 0, the numbers go up.
Hey, Elizabeth.
In exponents. Yeah.
Can you type in the sequence of numbers? So I think well, let's try and count in binary. I think that will help, Isaiah. So
did I do it wrong?
Yeah. So let's say 0. We're going to say 0, right? And then for 1, we're going to say 1. But for 2, we got to say 1, 0, right? So we need to get comfortable with that. And then I think Isaiah should call out the binary numbers for the corresponding decimal numbers on the left-hand side. And I think that will help because I think we run the risk of losing several students by.
That's like Isaiah looks stupid. I think somebody else should do it. I don't think I'm gonna get it correct. I'm still.
No, Isaiah, no, that's not allowed. Okay, that's not allowed. You got to do it now. I'll help you. All right. So hey, Elizabeth. So type in a vertical column of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 11. Right? Yeah, that's fine. 0, 1 is fine. Right? So do all the way up to 11. Right? Now Isaiah and I are going to do what is that? We'll do binary on that side. Okay.
Okay.
Yeah, Isaiah.
Yes.
Okay, good. Okay.
So
I don't know, right? So I'm pretty sure lots of other people want to do that too, but they're not just volunteering. Okay, they're just passive bystanders. That's fine. Okay, but we're going to do it. Just at least keep watching this. All right. So you need to understand this really properly. This is really solid foundation for doing good programs later. Okay, 0. All right. So this on the left hand side, Elizabeth has got all these decimal numbers. Okay. So on the left hand side is planet 10 land. Oh, your base 10 land. Okay. So on the left hand side of the equals, right? So and by the way, LHS and RH. You see that in assignments and all these other places. Many people, those are terms bandied around. LHS and RHS. LHS, RHS basically means left-hand side, right-hand side. Okay. LHS sometimes in C++ is also called an L value, right? Later on, we'll encounter this. L value means something that can be assigned to. Something that can go on the left-hand side of the equal sign is an L value. Right. So, and that is very important. It's a distinction that will become important in C++. So remember this later on when we're actually doing C++ coding, this will come back, right? Oh, in lecture number 2 at 1 hour and 47 minutes, we talked about L values. That's what this one is, right? So, okay. All right. So here's what we're going to do on the right-hand side. Isaiah, tell me what we're going to do. So everything should be in binary now. So tell me what we do for binary 0.
0.
0. Thank you. All right. Yeah, give her a second. So while she, yeah. All right, decimal, and then that side to binary. Okay, great. Okay. Great. So 0, 0. Okay. So what are we going to do for 1?
1.
Okay, 1. And you got one more. What are you going to do for one more now? Now
One.
forget about the decimal side. Okay. All right. So yeah. So what are you going to do for 2? Well, but you don't have a symbol 2.
1, 1.
No, why would you do 1, 1? Because if you do 1, 1, then you're saying I'm going to.
Oh, I mean 1, 0, 1, 0.
1, 0. But you can do 1, 1 because 1, 1 is the way that we were used to doing it before place value system, right? Because in place, think about tally marks. Do you remember tally marks? We used to do that in school for creating these tally marks. Hey, Elizabeth, do you know about tally marks? We used to do tally marks, right, in school a long time ago, right? So to do histograms and all, so to count things, you just make marks, right? So and then you can count these marks. You know, the marks. You know, people make marks on wood with knife and all, right? So so count these marks, and then when you get to 5, instead of making the 5th one, you basically make a diagonal one, so you can count in batches of 5 after that. So those are called, I think they're called tally marks. Okay, so if you had tally marks, you would basically do exactly what you did, right? So you would say, all right, I'm going to count, and that is base 1. Essentially, tally marks is base 1, right? So because you're just basically keeping adding that symbol, tally marks is base 1, right? So we don't want to do base 1. We want to do base 2 because we have 2 symbols now, not 1. So let's exploit the power of the second symbol. Well, so what you did is actually a valid solution, but it doesn't exploit the power of the 0. Yes. You got 2 symbols, right? So why should you just use only 1 symbol and say if 2 is basically 1, 1? If you only had 1 symbol, you got to use tally marks and say, well, for any number, I got that many tally marks. If you got 2, I got 2 tally marks. 3, I got 3 tally marks. Yes?
Yes.
Okay, that was base 1. Yes? So it's base 1. So we're saying now, instead of that, I have a special symbol, which is also another symbol. We got 0 in addition to 1. So I don't have to use base 1 anymore. So I'll use base 2. In base 2, I can say 0 is my first symbol. Okay. Now I have another symbol, 1. To get to the next symbol, I'm going to do my gasoline station thing. So I'm going to move this guy over and start here at 0 again. Does it make sense?
No, that don't make sense. You say you slide everything over and starting with 0 again?
Yeah, so that's what she's done here, right? So actually push the 0 over to the right-hand side by 1 character and the 1 over to the right-hand side by 1 character. So you'll see that that's exactly what she's done, right? So no, on top, on the previous line, the 1, line up the 0 and 1 with the units column. Okay, all right, so now you see the gasoline meter operating, right? So the 0 and 1 are like that's a wheel.
Oh.
Okay.
Yeah.
No, so what's going to happen now? So so when we pump more gas into the car, what's the next one? What's if I get 1 more unit of gas? What shape am I going to get?
1, 0.
Oh no.
1, 1.
Yes, thank you. Yes, 1, 1. Thank you, Isaiah. Right, 1, 1. Okay. So what do you get after 1, 1? What do you get after 1, 1?
Elizabeth?
Yes.
I think it would be easier to see if you put 0 as 0, 0 and then 1 as 0, 1.
Yeah, I think that's a good idea, right? So I think who
Alright,
suggested that? Who suggested? Chris suggested that, right? Chris, was it you?
Yeah.
Yeah. It's actually a good suggestion. What Chris is saying is that add some more zeros to the beginning so all the wheels are visible. Right? So because you can add zeros to the beginning of the number, it doesn't make any change, right? Doesn't, because it's just 0 times 10 to the something. Yeah,
Okay.
Yeah, it looks nicer, yeah.
So then would it be 1, 1, 0?
I'm sorry. So the next one. Well, so what's going to happen to the next one? So tell me what will happen if they were both showing 9. If they were both showing 9, what would happen when I pump the next gallon? What's going to happen?
Did it go up?
What would happen to if they're both showing 9s? What would happen?
The next digit to go up. So like 2. Like when it go up to the next digit.
Yes. What would be the next digit? If it was showing 9, 9, 9, showing 9, 9, what is the next digit?
1, 10, 10.
No. Imagine that this is a gas station, right? This is a gas station. And in fact, make that in 3 digits. I think make them 3 digits instead of 2. I think it'll be easier. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Okay. So hey, Elizabeth, can you change the digits to 3 digits instead of 2 on the right hand side of the equals?
For all of them?
Yeah, all of them. Thank you. Yeah. That was basically Chris's suggestion.
Oh shit! You threw something at me. You messed up my whole brain.
Well, if you just add zeros to the leftmost value, it doesn't change like anything. Like if you put like
But you could put
0.1,
zeros on the
if you
front
just put,
of those decimal numbers.
yeah, like, yeah.
Yeah.
So if I did 0.1, that's equal to 0.00000.1. That's essentially, you know, just adding zeros. It's not anything like
No, I get that, but then I'm like, because he said add 1. I'm like, so am I just adding 1 to the front of it? So would it be the next
Yeah.
1?
So for the 4?
1?
No. So like you see these numbers up here, the two to the powers, like the
Yes.
2 exponents. So that's essentially what we're thinking about when we're looking at these values and going from decimal to binary. So like for 4, we have the third place is the value of 4. Or like so if you have three slots, like let's say 100, we know that we have 1/100. Or I guess that's a weird way to say it. So if we had like 115 in decimal, we have 1/100 plus 110 plus 5 ones, right?
Okay.
And so in binary,
I'm sorry. No. By the way, in my classes, I don't like it when people say okay. You can say okay, obviously. Okay means I accept what you say. You should not accept what anyone says. Right, so don't say okay. So you only say okay if you understand it. So if you don't understand, say just I don't get it, but I can get back to it later. Don't say okay, meaning you can just proceed, because then Elizabeth will say we'll go proceed under the assumption that you actually understand this and go on to the next step, which will totally not make sense. Right.
So yeah, but I think Isaiah gets it though.
Yeah. Okay, but don't say okay. So don't accept even when I say, right. So that's the risk I have, right? Sure. When I say something and people say okay, I don't know whether I should go on to the next concept or not. I don't know if they're just accepting things blindly on faith or actually understood that, right? So I want to make sure. I'm sorry to interrupt, but just feel free to interrupt. And by the way, okay, I want to say, it goes for a whole lot of people, not just Isaiah, right? Those of you who are still struggling with basic concepts, just get together, find a time. Find a time later today or tomorrow, maybe 1 hour, 2 hours. I can do a separate Zoom, private Zoom for you guys, okay? And then we can just work through some basic problems and some concepts and get solid on that before next week. I'm happy to do that, but we can absolutely do that. So keep that in mind. That's also possible.
Yeah, I'm free. I'm down.
Yeah, go ahead. Sorry.
So what's the fourth? Okay, well, so how we thinking binary? 0, 4s. Wait, what?
Yeah. So she's saying what 0, 1, 1 actually means. Right?
So yeah, there's one. Sorry for interrupt. There's one thing that really helps me as a beginner too.
Wait, what?
It's about the exponent. Like 100, it's 10 to the power of 2. 100 is 10 to the power of 2. 10 is 10 to the power of 1. So in binary, we put the base as 2. So we start reading the binary number from the right to the left. And the first number is when 2 is to the power of 0. And the second one is 2 to the power of 1. And then we start adding them up. So I'm not trying to find the number. I'm calculating backward. Like this is the decimal number, and I try to think in my head that how can I add them up. That's how I do it. I hope it helps.
Hey, Elizabeth, just want to point out that 0, 1, 1 is 3 in decimal.
I think one of the challenges here is that Isaiah, you have not yet read module 0, right? If I'm not mistaken.
Yeah, you're right.
Yes. So I think so. We shouldn't be spending a lot of time.
Okay.
No, I'm not saying that we shouldn't. What I'm saying is that we should do a separate class for you, right? I'm happy to do that. Not just you. I'm just saying Isaiah, but there's maybe 10 other people in class who haven't spoken up, right? Who are in the same boat. So I think you just get together on Slack or Discord, or just email me saying we as a bunch, we'd like to get more help on concepts, right? So let's get together, we'll work through some examples. Then I can also point you and introduce you to some folks in the STEM Center who can sit with you, right? 24 hours, they're open 24 hours. And there are people just like me, right? Waiting for an opportunity to sit with you guys at a table and describe, right? Virtual table and describe these concepts in great detail. So there's all these things paid for by the department. So we can absolutely do that. Okay. So, but after what is Elizabeth is doing now, let's just keep marching ahead into what we were supposed to do today. Because this is 9:10. I want to talk about floating point and other things. We want to get solid on that. And then we can come back to this more basic representation issues after you've read module 0, right? And then I'm happy to talk about that in a separate class too, right? So let's take a break from after Elizabeth's done, right? With this, let's say 9:15, right? 9:15, we can start talking about floating point. We can start talking about floating point numbers, and you can start, reading module 0. It's going to be, when I say 2 hours, it's not 2 hours of clock time. Lots of people say, I spent 2 hours reading now module 0, or thinking about modules. No, it's not 2 hours of clock time. It is actually 2 hours of mental time. So that 2 hours may be spread over an entire week. Who knows, right? So so it takes a while for it to sink in. And I think people are just unkind on themselves and thinking that, they don't give it enough time and they kill the seed, saying it doesn't germinate.
Oh, I get it now. Those are based off the exponents. Okay.
Yes, exactly.
Yeah. That's so that, yeah. I was like, what the I was missing it. Okay.
Yeah. So you see these, like if I don't know what is 2 to the power 5. There's no one at the
I definitely see it now.
32.
32, and then
64.
64. Okay, thanks, guys. There's just multiple. Okay, I got it. Okay, yeah. So basically, instead of thinking in tens, hundreds, 1000s, we're thinking in multiple, exponents of 2. So it'd be 2, 4, 6, 16. The 16th place, the 32th place.
So thinking number of bytes and stuff, yeah.
And what you're doing is you're representing a number by putting multiples of 2 together.
Mm-hmm.
Powers of 2.
Powers of 2.
Yeah.
You said multiples once before and then corrected yourself.
Okay, so the first digit represents 1. The second one represents 2 2s. The second one 4. The next one will be 8. Next one 16 accordingly.
Yes. Yeah.
Versus the number of digits that we use into adding them up to figure out the digit.
Yeah. So what would 8 be?
No, 4. Let's do 4. 4. Yeah, for 4.
Okay, 4. Yeah. So what would 4 be in binary? Like just think it out, even if you're not entirely sure.
Isn't it 1 0 0?
Yes. Yes. Thank you. All right. Let's leave it at that. Okay. All right, good. Isaiah, so you agree that you are going to read module 0 from now?
Yes, right? I get binary, but I will read module 0. I get
module
it.
0, and then this is a good time after having listened to Elizabeth's explanation. Is the time it's better for you to read module 0, right? Perfect. So read it, and then not just you, right? Get together with some other folks in our class on Slack or Discord, right? And if you guys together, or even if it's just you, doesn't matter. If you want a special class, okay? If you want a special class, 1 hour on Zoom with me to go over some fundamental concepts, I'm happy to do that. I can also personally introduce you to some of the good tutors in our STEM Center, okay? Who can basically sit with you. Yeah, he can sit with you.
Okay.
Hey, thanks, Elizabeth. Thanks for driving that. That was very.
Thank you so much, Elizabeth. I appreciate you.
Yeah. It's like a weird thing to think about. When I read the module, it didn't really hit home until we had our first class.
Yeah, it absolutely takes a while. I can understand it when people say, well, I read that it makes total sense. Well, maybe that's because they did read it one time or think about it once and it didn't make sense and they were thinking about it for a long time, right?
Yeah,
and eventually it clicked, right? So
exactly.
Yeah. So things are hard, like this, right? Like this are hard. So you've obviously thought about it once before, or now you just remember. So this is great. Thank you so much. Thanks. Yeah, very useful. Very useful. I'm glad it's all recorded too. So you can make, annotations with time marks saying, hey, to listen to Elizabeth's explanation of binary numbers, you go to this, T. I don't know.
I could do, and
Well,
I'll
YouTube,
do
you
this
can
little,
annotate.
I'll do this little blurb in like hex and octal too. I'll just write this little bit, like how we think in hex, how we think in octal too. It's the same thing, but it's good to just have a visualization of the numbers going up, I think.
Sure. Yeah, feel free to share all these things on Reddit. I don't know, for some reason, the Reddit, the forums are quieter this quarter than last quarter. So you should feel free to talk more on Reddit. I'm there to delete posts that, that may be risky. I'm happy to delete these posts. So you can feel free to talk whatever you want. Yeah, hey, Mark, yeah, go ahead.
So I'm going to ask a question that'll segue to the floating point, which is, would you say that there's a good analogy between scientific notation and floating point numbers?
Yeah, I think so. In fact, I think the scientific notation could have
Well,
been.
I think that it might be helpful if we just take a quick, hands up, hands down poll of who's familiar with scientific notation. That way we can.
Yeah, thank you so much for. Yeah, I might have just started talking about it otherwise.
If you're on camera, just put your hands up if you're familiar with scientific notation. If you're not, then we should go over that. All right, let's see. Looks like most of us are, but I think I'm seeing one or two hands down. Oh, wait, actually, Isaiah's got his hand. Christopher.
All of you. Not you, Ray. You, Ray. You know about scientific notation too. All right, good.
Okay,
So
and then we actually have thumbs up from people that don't have the cameras on, which is great.
What was the question?
Are you familiar with scientific notation?
Oh, yeah.
Okay, yeah. So I think that's almost anyone. If you're not familiar with it, please don't feel embarrassed or anything. It's important that you learn, and if you got a problem wrong, if you're on camera, you still get points, you still get credit. So if you need a little explanation on how scientific notation works, now is the time to let us know.
I can basically step away at this point. Well, not step away, but basically disappear. If you guys prefer that, I think that's worked out really nicely previously, right? You can call out to me, right? Anytime you want me to butt back into the conversation, just call out to me.
Well, so I'm just gonna share, this is page 31 of Mod 0, and you can see this is kind of the representation of a floating point number in binary. You can see it's a regular byte with 8 bits, but the rightmost 3 bits, those are not your normal digits. Those are the exponent. And then on the leftmost 5 digits, that's the mantissa. So the idea is it's just like scientific notation. The mantissa, the left side, is whatever precision of decimals that you need. And then the exponent on the right is what it's multiplied to. Is that approximately correct, Anand? Okay, he's muted himself. Well, he's not stepping in, so I'm going to take that as a sign.
Okay, all right. I'm sorry. Yeah, I wasn't listening. I'm sorry, Mark. I missed what you said.
Yeah, I was asking. So the first 5 most bits on a floating point number is the mantissa, which is a number, and then on the right is your exponent, which you multiply it by.
Yes, it's just a convention that we have chosen to use in module 0. Because in the real world, a floating point number is not just 1 byte. Yeah, it's very unrealistic to have a floating point number in 1 byte. It's very little. So it's a convention I've used in module 0 to illustrate the concept of floating point notation.
Okay.
And basically to say that, floating point is called floating point because there is really no point. We put the point and then float the point into the correct position based on the exponent. So because a point floats into the correct location, it's called floating point representation. So, and to make that point, I used 8 bytes. I think in the real world, how big are floating? 4 bytes. right? 4 bytes. In C++, I think floating point numbers are 4 bytes long. That's 4 bytes is 32 bits. And in the 32 bits, I don't know. Maybe I think the Mantisa, I think the exponent is probably 12 bits, right? They use 12 bits for the exponent, and then 20 bits for the Mantisa. I don't know. We can find out, right? You just Google. There's one search away, and you can find it.
Can. But for the quiz, this is the kind of format that you'll be looking at and analyzing. And to give an analogy to scientific notation, it would be the left side. Say you want to say 1,000 in scientific notation. You could say it's 1 times 10 to, I think, the third, right? Someone please step in and tell me if I'm wrong.
Oh, I'm sorry. Yeah, did you want? So you were saying what was that? A third?
So the idea is, say you want to say 1,000, and you want to represent that in binary in scientific notation. 1,000 would be 1 times 10 to the third. That'd be one way of representing it in scientific notation, right?
No. So in scientific notation, I think the convention in science, and scientific notation is different, by the way. This is a very subtle difference between scientific notation and the way we do floating point. And that's I don't know. I think that Don Knuth actually brought this up in one of his, I don't know, was it lecture or some rant, right? Some interesting rant. All his rants are interesting rants, right? So he brought it up about the Mantisa and logarithms and mathematicians. Anyway, so as I was saying, 1,000 is basically in science. In scientific notation, we write it as we have exactly one non-fractional number. So we basically have to say something point something, right? So 1,000 we write as 1 point something, right? So in this case, 1.000 times 10 to the 3. So 1 times 10 to the 3. That is a scientific notation. For pi, for example, for pi, we don't say 0.314 times 10 to the 1, because that's also pi. We say 3.14 times 10 to the 0. That is scientific notation for pi. There's multiple ways of saying the same number in scientific notation, right? Because you can shift the mantissa and then decrease the exponent. 3.14 times 10 to the 0 is the same as 3.14 times 10 to the 0 is the same as 0.314 times 10 to the 1. Yes? Yes or no? It is the same as 314 times 10 to the negative 2. Would you agree that 3.14? Yeah, it's the same.
Yeah, you're just moving the decimal, and it's the same number.
It's the same number. I'm just floating. I'm floating the point. I'm floating the point by tweaking the exponent. I can change the exponent and float the point.
Anyways, the reason this is interesting is because normally when you write a number with a decimal, you use decimal notation, which is shown actually up here.
Yeah, in decimal it's 10 to the. In binary it is also 10 to the, because it's 1 0 to the. But 1 0 in decimal is different from 1 0 in binary is 2, right? So it's 2.
Anyways, this is one way to write a fractional number without a radix, the period, and that can be pretty useful for data representation. And being able to work with these numbers requires you to translate this, if I'm not mistaken, because when you're adding two floating point numbers, if the exponent is not exactly the same, that's if you try to add the exponents, you're doing it wrong, basically. And what you would have to do is translate it to a different representation so that you don't end up adding the exponent. Because say I wanted to add 0.00001 0.000, I couldn't just add this, because this on the right here actually means this number is 15 times 2 to the negative first, which gives us 7.5 in decimal. However, if I wanted to add 1 to this, the correct answer would be 8.5. But if I just move a 1 here, it would be 10000 to the 111. That would not be 8.5. That would be something, if I'm not mistaken, it would actually just be 0.1000 in 0.000 exponent, which is 0.123. 4.
Oh,
Yeah,
hi, sorry. Yeah, I have a question.
yeah, what's up?
So why the right-hand side, the 111 means -1?
Because it tells us it's in 2's complement format. How would you represent a negative number if you don't have a negative sign? We've done 2's complement in last lecture. It's just the way to represent -1.
Oh, okay.
Yeah. In this format, there's some limitations. Obviously, 5 digits is not much to work with. The maximum value that can exist in this. But the point is, if you want to add 2 floating point numbers, you can't just add the left and then add the right and then hope that that's going to work out. Normal binary addition will not work with floating point numbers. You have to convert them into non-floating points. You could do it in decimal like I did for 7.5 plus 1, but this is 7.5. And if you go to the chat window, which I'm having a hard time accessing because I'm streaming, towards the top, it's like the second video, I think, has a 3-minute video on how to add floating point numbers if that's something that you're going to end up doing. Are there any other questions? If there isn't, I'm going to stop sharing and
I
let
have a
someone
question.
else. Yes.
So for the decimal 2 power of -1, that equal to the 10 power of -1 in binary, right?
To the -1. Wait.
Because it pushes, when you transform to binary, it pushes the decimal in front, right?
Yeah, it's kind of like when you're looking at, where's the exact example of, yeah, right here.
It's like
so
shifting,
it's kind of like,
yeah, like this, right?
Yeah, when you multiply by 2, you're shifting the digits to the left. You see it's 0, 0, 0, 0, and then this one it's 0, 0, 0, 1. If you divide by 2, it would shift everything to the right. And so multiplying 2 by 2 to the -1st is the same as dividing by 2, which is a right shift, which is why it's 7.5 instead of 15. Because 1111 shifted to the right becomes 111.1, which is 1 plus 2 plus 4, which is 4, 5, 6, 7. And then in 0.1 in binary is decimal for 0.5. So that becomes 7 plus 0.5, 7.5. Does that make sense?
Yeah.
Sweet. Are there any other questions? Okay, and I'll hand it off back to Anand for more discussion of floating points with that basic explanation out of the way.
I have another question though.
Yeah, sure.
So they're all 8 bits, right? Then how can we know that this is a floating point instead of a regular number?
It's going to be given to us, basically.
Yeah, because in the example about 7.5, there it's highlighted in the last 3 digits. Then I know that that means the exponent, the power of the 2. But yeah, that's my question. Thank you.
Pretty much, if it's not told to you, there's really not a great way to know. Anyways, I'm thinking I'll just put together a random floating point. It's really basic.
Actually, I was just coming back here when I heard Chan Yi's question. Oops, hang on. Yeah, how do we know? How do we know if it is? It is very related to the other question that I think Isaiah asked and Elizabeth answered, or something like that, about context. So here, next week, for example, here's this really interesting thing, right? Next week in your program, you're going to be declaring these variables, right? You're going to say to the compiler, I want a floating point number. I want a regular number. I want a character. And you're going to be telling the compiler, give me these things. And in your expressions, right, in your next quest even, right? So you're going to be writing A equals B times C. Yeah, maybe you're going to say, take the product of B and C and put it in A. You're going to be saying that somehow, right? Well, I'll show you how to do that. So since you're going to be saying that, now B times C, you would have learned in school, obviously, right? All of us in school, we would have learned how to multiply two numbers, right? So for multiplying two numbers, we use an algorithm, right? We take each digit and multiply, and then arrange them and shift them, and then add them all together. Do you remember the algorithm that we use to multiply two numbers? Yes or no? Right, if I gave you two numbers, 75 times 23. How do you multiply 75 times 23? You write 75 times 23 and then say, okay, 3 times 5, 15, carry the 1. 3 times 7, 21 plus 1, 2. So it's 75 times 3 is 215, right? Or 225, right? So I write 225. And then you take the 3 times 75, or whatever it is, right? So you add, and then you add those two together. I don't know if we need to do that on the screen. But do you remember how you do the multiplication algorithm that was taught to us in school? I don't know. No, yeah. All right. So, the thing is, the algorithm was taught to us, but really the reasoning behind it, and like I think we went over this before, right? The reasoning behind why we do those things, the algorithm. Why does the algorithm work? That never was taught to us in school. It was left to us for us to, with lots and lots of experience, to figure out why the algorithm works. I don't remember being taught the algorithm, right? We're not taught why the algorithm works. They teach us the algorithm, but they never. I was never taught. Now they do, right? So when my daughter went to school, they actually taught her why the algorithm works, but they never taught me. Right? They said this is the algorithm, learn it, right? And then we figured it out eventually. So anyway, so the point I'm trying to make, eventually what I was trying to drive towards, is that when you multiply two integers, the algorithm, the procedure I use to multiply two integers is different, right? So think about it. So we say 2.5 times 2 equals 5, right? So we say that very quickly, and in our mind it's the same, right? So we say 2.5 times 2.5 times 5. Yeah, 2.5 times 2, 5. Yes. So in our mind it's the same. Whether it's 2 times 2 equals 4 or 2.5 times 2 equals 5, in our mind it's the same. Yes, but for a computer, for a procedure, right, a mindless procedure that needs to operate on that, they're fundamentally different. The fundamental different algorithms, different procedures. You can't even say it's like go and buy ingredients to buy a cake, or go and buy ingredients to make something else, to make a pasta. Right? Two different sets, completely different instructions, two different recipes. But we think it's the same. How does it? But so when you say to the compiler, I have two floating point numbers you gave me, right? I want to multiply those and get the result of that, right? And in another place, you say, I have two integers you gave me, multiply that and give me the result of that. Two different things. It's like saying, bake a cake and give it to me, or make pasta and give it to me. Two different things. But we use the same symbol, star. Why is that? We use the same times, right? In our mind, times is actually overloaded. That's called overloading. In English, words are overloaded all the time, right? So overloaded, the word overloaded means it's overloaded, right? So meaning it has more than one thing on it, right? So when a truck is overloaded, lots and lots of things on it. So overloading a word in English means that word carries lots and lots of meanings. Like that in C++, you can overload things, right? You can overload function names. In fact, you can, even C++ gives you the power to overload operators. So when you say plus, right? A plus B, plus. You can say, I'm going to overload plus, right? I can give plus many meanings, right? So plus, if you're called with two integers, do this procedure. If you're called with two other things, not integers, but you're called with pasta and salt, right? In fact, you can define a plus. You can define a plus to take two string arguments and to look at the string arguments and say, call plus with pasta and salt. Do something completely different from 2 plus 2. You can define a plus that says, okay, well, you know what? I got a procedure for doing 2 plus 2. I want to define another procedure for doing 2.5 plus 2.5. Because adding two floating point numbers is different. Adding two floating point numbers is different procedure from adding two ordinary numbers. Because well, you can add 3.14 and 0.5. Yes, you can't do that, right? You can only, before you add 3.14 to 0.5, what do you have to do? You have to make sure the two exponents are the same. Otherwise, you can do a standard addition, right? So you got to take the 3.14 and change the 3.14 into 0. I don't know. 3.14. 3.14 times 10 to the 0, and then you have 0.5 times 10 to the 0. Yeah, okay. Let's say 3.5. I was trying to come up with a problem in which you can add AB times AC, right? You got to factor out the A, or you got to make sure the two A's are the same. So given two things, in order to A times 10 to the something, B times 10 to the something, you got to make sure the 10 to the somethings are the same. So before you can factor it out, and then you can do A plus B. I don't know if that would make sense. Let me actually try. So before we do 3.14, that's 3.14 plus 3.14 times 10 to the 0. Yeah, okay. All right, good. 3.14 times 10 to the 0 times plus 5 times 10 to the negative 1. Okay, so that's easier. 5 times 10 to the negative 1. So 3.14 times 10 to the 0. Everybody's familiar with scientific notation. Please follow along, right? So 3.14 times 10 to the 0. That is pi. Now I have 5 times 10 to the negative 1. Not the same exponent, because that was 10 to the 0. This is 10 to the negative 1. So I can add the two different animals. So in order to add the two, what do I need to do? I got to turn the 5 times 10 to the negative 1 into something times 10 to the 0. Then I have 10 to the 0 on both sides. I can factor it out, and I can add these two together. So the 5 times 10 to the 1, I'll turn that into a 0.5 times 10 to the 0. No, 5 times 10 to the negative 1. I think it was 5 times 10 to the negative 1. Okay. We'll keep it at 5. Let's make it 5 times 10 to the negative 1, right? So then I can turn the 5 times 10 to the negative 1 into 0.5 times 10 to the 0. Yes or no, so far?
Yes.
Okay, now I can factor out the 10 to the 0. And I can say it's 3.14 times 0.5, 10 to the 0. So it's 3.14 times 0 plus 0.15 is 3.64. So it's 3.64 times 10 to the 0. Yes or no? Okay, so by changing the two exponents, I can do regular addition, but I cannot do regular addition without changing exponents. So the procedure to do floating point addition is different from the floating procedure to do regular addition. So how does the compiler know? How does the compiler, so going back to Chanyi's question, how does the compiler know? If I do A plus B, how does the compiler know that it should call this procedure and not that procedure? They'd be different, right? So the compiler knows because by context, going back to Elizabeth's answer from before, by context, the compiler knows that A is a floating point number because it was declared as a floating point number. Therefore, I should use floating point logic here. I'll use a recipe for pasta here because A has been declared to be pasta. So the context comes into that. So that is why declaration is so important in C++ when we get to programming later on, when we declare the types. Even most of type-driven languages like Java or C++, the type is very important because it signals to the compiler, use the most efficient algorithm without having to make runtime decisions about what the type is. Making runtime decisions about the type is really slow, right? It's even slower than making interpretive decisions. Maybe the Java bytecode is even slower. Java bytecode is even Java bytecode is faster than Python, right? So Python is the power of Python is just because of the ubiquity, right? So all the libraries and everything, but it's slower than Java. Because Java bytecode, even though it's interpreted like Python, it's faster bytecode. It doesn't have to go through the runtime decisions of type decisions of in Python for Python or JavaScript at runtime the system has to decide whether he's using a variable called A, right? Is that a floating point number? Is that a string or a floating point number, right? All these decisions have to be made at runtime. So you can imagine how slow the system will be compared to Java, where that decision at least has been made at runtime, before runtime. Or go all the way to C++. Well, even that, taken care of even that has been taken care of. The computer knows exactly what to run, right? It knows it's a floating point number. So all of those levels of granularity that you want to bring into the system to make your the program as fast as required for the situation, right? So many times I see programmers who say, I want to use C++ for that. I want to use, no, it's just because C++ is such a powerful language, it's not the tool for everything, right? So for some languages where speed is not critical, but understanding is more important, or the ubiquity or the availability of these libraries, right? They're more important. You should not be using C++, right? So maybe you should. I don't know. But this is a conscious trade-off. You got to think about these things, and I think that is usually missing. And not usually. Sometimes it is missing when people make these decisions, saying, well, I know C++, so I should be using everywhere. No, just because you got a really, really fine chisel doesn't mean you got to go and carve a mountain using that chisel, right? You got to use a bulldozer first, and then for the fine points, you can use a chisel. No, I don't know if that was useful, but John, you asked an innocent question for like 10 seconds, and then I jumped in and took over. But I'm sorry to do that. I didn't mean to barge in like that. I can disappear again. What time is it? Yeah, you got 10 minutes. You guys want to spend the 10 minutes talking amongst yourself, or you want me to talk about something in particular? I'm happy to do that.
I think the first question I have is the highlighted digit I have, is that supposed to be 2 to the 0 or 2 to the first?
Oh, that is 2 to the 0. Yeah. So yeah,
okay.
that is.
So if I put that, if I put a 1 there, it would actually be 0, which is still wrong.
That's why it's unintuitive for us, right? So for humans who read language from left to right, it's unintuitive for the powers of 10 to increase going to the left.
Anyways, I just did a very simple operation, taking the number in floating point format that was displayed in mod 0, page 31. And I wanted to see what it would look like if we add just 1 to it, although this technically...
Oh, you add 1 to it.
Yeah. What is this number plus 1? And I just want to emphasize, it is not this. This is what you would get if you just did regular, straight
addition,
right? If you let this be its own area, and the moment that you exceed 111, it just becomes 000. And if you add 1 to this number, it's going to put a 1 at the farmost left point. But we know, because it gives it to us, that this number right here is 7.5. And intuitively, in decimal, intuitively know that 1 point plus 7.5 is 8.5. But looking at this, we know that this is just, I think it's 8, right? And we can tell that that's off by 0.5. And to give an analogy of why you don't add floating point numbers like that, I use a decimal example, which was kind of copying what Anand was saying. Does this look about right, Anand, or Professor? Okay.
Oh, I'm sorry. Yeah, hang on. Did you ask me a question? I'm sorry, I missed that.
Yeah. So you're saying that in your example that you can't add numbers that are to different exponentiations.
Yes.
So to try to add these two numbers together and then add the exponents, which would be just like doing this, you would be doing that when the real answer is this, not that. So
thanks for
in order to add, when you have to add binary numbers, what you do is binary numbers in floating point format, you have to translate them to what I call regular binary, which I could, just something that isn't in floating point format. A lot of times you use floating point numbers because you're going to have a radix somewhere in the number, like it's going to be fractional probably. And so you can either represent it in decimal, so it's a lot more intuitive, or you can do it in binary, so that the process is just like you do in all binary processes. Once you translate into this, you can go ahead and solve it in binary or decimal and translate it back. And then the last thing that I wanted to point out is how do you represent these sorts of numbers in floating point? Well, since 8.5 written in radix format is 1000.1, we can shift everything to the left and then just in the exponent have it divide by 2. So this shifted 1 to the right should be the same as this number if I'm not mistaken. Normally with floating points, there's all kinds of ways to write a number, because this right here, the exponent, can shift it to the left or right, however many digits are available. This particular number, though, I I fail to see how I could represent it in a different way in floating point format, just because you can't shift that left or right. It's got no room. Does that make sense? Does that look accurate to you?
I have a question. For the exponent 111, how do you know it's 2 to the negative 1 or like 7? Like
This
how can we
is
tell for the
this is
exponent?
yeah. This one's just
If it's
given to
negative or
us
positive.
in mod 0. And I guess you should probably also note that the 111 is 2's complement -1. It's a good question.
But if
and
we just see like 111 in the question, how do we know that?
I'm
which
sorry,
one
what
is
was the question?
percent?
I'm sorry, what was the question? Maybe I can
Like,
answer it.
the sign, how do we know if there's a sign like?
Oh, I see.
2%?
Yeah. You're asking, how do you know if it's a
Or
negative exponent or a positive exponent or a negative mantissa or positive mantissa? Yes?
Yeah.
Yeah, so I think you can look it up, but I believe the floating point representation, both the exponent and the, I think the exponent is stored in 2's complement notation. I think they're both stored. The exponent and the mantissa, they're both in 2's complement notation, I think. Because I used to think that the exponent was in sign magnitude, but maybe that's not true, right? Maybe they're both in 2's complement, but basically they're both signed numbers. They can both have positive and negative values, exponent and the mantissa.
So the left one will always represent a sign. The 1 and 0 will always represent positive or negative. Is that right?
That entire, so if you take that, so in the example that Mark has got, he's got 5 bits, right? He's got 5 bits for the mantissa and 3 bits for the exponent. Yes.
Yeah.
So those 5 bits basically represent a 5-bit signed 2's complement number. Signed number. 2's complement is just a representation we choose, right? So we shouldn't fixate on 2's complement, because 2's complement is a way in which we can store negative numbers. All we need to know is that the 5 bits represent a number that can be negative. How we choose to store it is using 2's complement. How a particular architecture used to this maybe my Mac says, oh, all the numbers that are negative, I'm going to store using 2's complement, right? So this particular architecture, maybe some other architecture is inferior, because the sign magnitude is actually inferior to 2's complement in many ways, right? So maybe some inferior architecture is out there, some other manufacturer, some computer, right? Pair or something like that. They have a machine, is cheaper, but uses sign magnitude notation for all floating point numbers. No, all signed numbers, negative numbers, right? So it's inferior architecture, but it's out there. Yeah, but it'll still work. It'll still work. It'll do all the right things. It'll be slower and less efficient. That's all. 2's complement is actually a very efficient form of storing, because no bit pattern is wasted. Everything is used. In sign magnitude notation, if you think about it, the 0 pattern is actually, there's 2 zeros, right? 1 followed by all zeros, that's a 0. 0 followed by all zeros, that's also 0. So -0 and +0. Why have 2 symbols for 0? So which means 1 is wasted. It's inefficient, right? So in 2's complement, we say, no, absolutely no wastage. We're going to use every single bit. Every single bit that's out there is going to have information for us. And that is the power of the, so that I think that both the exponent and the, because there's no reason why you should use sign magnitude for anything really, right? So the exponent and the mantissa, they should both be 2's complement numbers. Oh, stored in 2's complement, they can both be signed numbers. And by the way, I also want to mention one other thing, right? So I think there are 2 classes of people in our class, and 2 groups of people, not 2 classes, 2 groups of people in our class. The first group is a set of people who have already read module 0, okay? And I might be wrong here, but I think that both of those groups are non-empty, meaning we know at least there's one person in both, right? So for example, Isaiah for sure said he hasn't read module 0, but I am sure that he's not the only one, right? So there's more than one person, right? So I think there are 2 people, 2 groups, group A and group B. And I think, right, if I'm not mistaken, that everything that Mark went through here on screen, right, will only make sense to someone in group A who has already read module 0, because I'm looking at it. I'm looking at it with both perspectives. I'm saying, okay, well, what Mark says makes total sense to someone who's read module 0. Now, does it make sense to someone who's not read module 0? No, this is like totally not. I cannot see anything, right? Yet this is what he should be doing. right? So which means that other people need to read module 0, and fortunately this whole thing is recorded. So after reading module 0, you should go back and look at everything that Mark has done, right? And now it doesn't make any sense to you, but after module 0, you should go back and do the same thing, right? So read this, maybe watch it at 2x speed or 1.5x speed or something like that, and it will make a great deal more sense. But don't give up, right? I think that's what I was fearful of when Mark was driving this. I was fearful that, okay, what about all these other people who haven't done module 0? Are they going to drop at the end of this week, right? No, so we should not drop. If you're frustrated, read module 0 and come back to it, right? And watch Mark's video, right? One more time, right? And hopefully you'll even have time marks. Someone might, comment on the video saying, well, at 1 hour 43 minutes, T equals, I think it's on the URL line, you add T equals 1H43M. It'll basically, when someone clicks on the link, it'll straight away start playing this part of Mark's demo, right? So
I will say that I'll be putting these notes on the Reddit, and I think that I didn't have the perfect grasp of floating points before reading, actually even after reading Mod 0. So I think this might help to have sort of side by side when reading Mod 0 to sort of understand these.
Sure, absolutely. Go, feel free, and I will chime in whenever possible and request it. I don't want to take away all the opportunities because some of you ask questions, and I'm pretty sure other people know the answer, right? And if I jump in and take the fruit away before they can get it, there's no use there, right? So please do. The other thing you can do is also right under the video and on the YouTube page, right under the video, you can say, make a comment there. And I think if you say anything remotely resembling a time mark, like 1:2:1:02:5, right? If YouTube, the UI will parse it into a time mark automatically and turn it blue, right? And someone can click on it and it'll fast forward immediately to that point in the video. So you can make a comment in the YouTube video section saying, hey, at 23:47, you can listen to Elizabeth's description of XYZ. Right? And things like that. That'll be really useful, right? So you don't have to go to Reddit and then go to YouTube. Anyone who just goes to the YouTube once, they can basically just look at the time marks, and that's basically our index, our content there. Right? And it'll be useful for other people too, right? Downstream, if you once you make those marks. Great.
Professor, I have
thank you. Hey, don't share your personal information, okay? It's really it's a real pain after that to weed these things. Yeah. Is there any way to delete things from the chat? I don't know.
If you're an admin, maybe, but
No, I can. I'm supposed to be admin, and I can. All right. Well, it's not even a Bay Area number. 719.
Yeah. You got me.
I don't know. All right. Okay. Cool. Maybe somewhere in Hogwarts. All right. Okay. All right.
Not as cold. It's about as cold.
Yeah. All right. So I hope this whole thing was useful. Thank you all for another opportunity. Thank you. Hey, Chanya, you have your hand up. Is there a question?
Yeah. I have a quick question. Sorry. So in the Mark's note, he said when we have floating points, we cannot add them up directly. But what if the one way I can think about is to convert them into binary. So is there another way that when we're doing the type in this when it's here, can we change them into the same the exponent?
That's a fantastic. Hey, Chani, that is such a fantastic question. Actually, I don't know if you really appreciate that question. That is really a great question, and I'll tell you why it is. I don't know. Towards the end of every class, someone seemed to ask this really cool, profound question. I think last week it was last class it was Isaiah, right? So what Chanyi said is that we have this fancy scientific notation with exponents and everything, and we're finding it hard to add. Why don't we just turn them into plain old binary numbers? Plain old numbers, and then we can add them. That's what you're asking, right? Without all these fancy, right? That is essentially in scientific notation too. You're saying forget about scientific notation, just turn them into regular numbers. So you don't have times 10 to the something, but you only have something point something. Yes, that's what you're saying. right? And so, but what is something point something? Something point something is times 10 to the 0. Right? If you get rid of a scientific notation, right? So suppose I have 31 point, 3 point. Let's not take pi, right? Let's take 1.729. 1.729 times 10 to the 3, right? 1729, Ramanujan's number, right? So 1.729 times 10 to the 3, 1729. So, but and I want to add that to something, and it's really messy with 10 to the something, and right. So I want to turn that, get rid of the scientific notation. I want to just turn that into 1729.0, right? So it's just plain decimal. You're saying plain binary, so I'm just saying plain decimal. So everything into plain decimal. Then I only have point something, right? So, but if I do that, what am I doing? If it's in plain decimal, it's just 10 to the 0. So I'm turning everything into the same exponent. Essentially, that's what I'm doing, right? So what we talked about before, I'm doing exactly the same thing, except that I'm constraining myself to make sure that everything is 10 to the 0. But all I'm saying is that this is just one step more general than that, is that we don't, it is okay, that'll also work, right? If we do, if we make everything 10 to the 0, it'll work. If we make everything 2 to the 0, that'll work, right? But I'm saying we that's great. We can actually take that one step further and say it doesn't have to be exactly 2 to the 0, exactly 10 to the 0. It can be any damn power of 10 or any damn power of 2. As long as the two powers are the same, it's okay. But if the powers are 0, then you've got what you said, which is both numbers are just binary. Does it make sense? I don't know if it even makes sense or useful, but it was a very nice point, right? It's a very nice point because it relates exactly what we're trying to do to to the notation. It's fantastic. Thank you for asking that.
I see. Thank you. So
I don't know if it makes sense, but it's certainly feel free to comment on that and ask any questions later in the forums. I'm happy to do that. And again, those of you who are still struggling with fundamentals, it's like super duper important. Okay, super duper important. If you are still struggling, get back to me, right? Email me, private message me, whatever it takes. Send me email saying you need more coaching on this. All right. If there's a bunch of you, I'll just do a class, or at the very least, I can introduce you to some. We have some solid tutors in our STEM center, right? And they love teaching students, and I can make the connection and make sure you sit down. At the end of the day, I find this is what it is, right? With many kids and also grown-ups, maybe, right? Is just not spending enough time, right? And so it's the use of the tutor, from what I hear from the tutors many times, is not that students are weak or they need to be taught things, but it turns out that most people are really, I shouldn't say spoiled, but they know this thing and they're intelligent enough to figure it out. It just needs someone to, with a cane to make sure they sit down and do it, right? So, right. So the tutorial is basically, all our tutors are basically, are trained not to give you the answer, and to make sure that you can figure out the answer. If you just spend time on it, you're not spending time on it, and you want the answer. No, this is not going to help. So I'm going to be here. You spend time on it, and I'll watch you, right? So and if you spend time on it, you will find the answer yourself, right? And if you don't spend time on it, and someone gives you the answer, it's not your answer. I can guarantee, right? It'll maybe get you through 1 or 2 doors in your life, but it will not get you to the to all the doors you want to go. So find the answer yourself, and that will get through all the doors. Hey, thanks,
Professor. So in terms of direct messages, which one would you prefer the most?
I don't care. Email is fine. The only thing is Canvas is a pain because Canvas messages will get deleted. It's not even stored here. It's stored in some Canvas server somewhere, and they just delete it willy-nilly sometimes. Archived and stuff. So yeah, if you want something that you would like to remain in for posterity, or at least in my inbox, use Reddit or email. That's fine. Confidential stuff is great. Canvas messaging is fine because at the end of the quarter, those messages will disappear, and I don't care. You don't care. Won't clutter up our inbox.
All right. Is there any other preferred contact method that you would like me to note down here?
Any way you can reach me, that's fine. You know, I don't care. Yeah, I'm on multiple places online, so you can just Google and yeah, I have good email filtration systems in place, so don't worry. Right? It's very unlikely that you send me a real message and it goes into spam. Okay. All right. So thank you so much for the opportunity to talk to you guys today. And it's about 10 o'clock. And thank you for today's class. And thank you, Mark, and all of you guys for driving, Elizabeth, Isaiah. Fantastic, right? I'm so glad to see you all guys, to see you all here today, and enthusiastic, right? And that's really the bottom line. And thank you all so much. I'll see you guys soon. Okay, next week, Tuesday.
So we email you right after class?
Yeah, email me anytime you want, right? But no, not. Hey, Isaiah, not before you read module 0.
Of course, I'll read module 0 first.
After you read module 0, send me an email, okay? And also to reach out to other people on Reddit and your classmates. And many people may not understand stuff, right? It's just that you spoke up and many other people didn't speak up. Yeah. Okay. So reach out, get together. There's, in the past, some of you guys got together, arranged a Slack channel, Discord, and groups to get together and talk about some challenging issues. So you can absolutely do that. Just remember that participation credit-wise, only the Reddit counts, right? So not these other channels. But you can use these other channels to get together in small groups. Why even? Just go to the STEM Center. It's open 24 hours, 7 days, 24 hours. It's open. You can get together on a table, people sitting around you virtually and talk to each other, and it's all confidential. This is really cool, right? So you can do that too. Except I suppose in Reddit, it's preserved. Yeah, or not Reddit, in Discord and Slack. But it's up to you guys, right? So it's just, but the important thing is at the end of the day, do whatever it takes to stay in the pool, okay? Because once you leave it, it's harder to get back in. Because once you leave it, I wouldn't say that to other people who haven't even tried CS2A, right? But once you've tried CS2A, if you leave it with a bad experience, it's less likely you'll come back, right? In fact, it's like a prodigal something, right? So it's once you try it and you leave, and it's harder to draw you back in than some random person who's never tried CS2A, because you came here and then you left with bitterness in your mouth. That has to go before you get neutral again. And so. Because you're here, don't drop, okay? Because that's the worst thing you can do for yourself. Because for me, it used to be the case a long time ago when I used to inefficient teaching methods, when every extra student would actually add a tremendous amount of load. And then I had a great deal of reluctance to add more students and so on. But now it's different, right? I've figured out ways in which information can be condensed in capsules, and guide each other, right? And things are getting more scalable and efficient, right? Education-wise, and so yeah, just feel free. Just keep coming. More people is fine, right? But commitment and interest is what it takes, and the more people, the more fun it is. And thank you. All righty. Is that it? Okay. So feel free to play around and yank me in at some point, and have a good weekend otherwise. Okay. Module 0. Next week onwards, we're not talking about data representation, except in passing, right? We'll start programming, and I'd like for one of you, other than Mark, okay, to be the driver, because next week we're going to actually start coding, right? Writing a program. I would prefer, if not Mark, not Elizabeth, not Vivian, maybe not Isaiah.
Professor,
right?
Can I volunteer for next week then?
Yeah, no, next week you should be in class, obviously, right? But I'd like someone other than you guys to take the screen. You don't have to know the program. No, you don't have to know the program, right? You're going to take the screen. Everybody will get a chance, even including Mark and Vivian and all these. Everybody will get a chance. But for next week, I'd like someone else to drive, and we'll take up the screen, blank screen, right? Open up Chrome or Edge or some browser on your computer, right? Open up and go to an internet site and start coding our C++ program and compiling it, looking at the errors, doing all that online live. Okay, we'll do that, and you don't have to do anything other than just type in what we as a group call out. right? We'll try all these things out. It's going to be really fun. It's going to be really fun. You got to get the taste. You got to get the taste, right? So, pushing you into the water from the edge of the pool, right? But into the 2 feet water, right? Hopefully you're all taller than 2 feet. Okay, so cool. Great. All right. I'll see you guys on Tuesday. All right. Bye. Bye.
Have a great day.
All right. You too.